Hello. In sigma notation, which is also known as the summation notation, we add up terms which are of the same type. For an example, if we want to add terms, say like 1 type, that means if you have sigma 1, then that means it is 1 plus 1 plus 1, and normally this goes on up to n terms. So we normally say that when we have the variable n to be varying from 1 to n, as such, then it will go on up to n terms. So this is an example of sigma 1. Now we can similarly be having, say, sigma n, we can be having sigma n square, we can be having sigma n cube, right? So if we talk about sigma n cube here, n is going to vary from 1 to n, or in other words, as it is the sum of terms of the n cube type, so as such it will be 1 cube plus 2 cube plus 3 cube, and all of this is going to continue up to n cube, because remember, n is the last term, right? So here, as such, I will quickly discuss all of this. Here we are talking about sigma series, or we are talking about sigma, which is a Greek alphabet which represents summation notation, and here we normally talk about the variable to be varying between 1 and n. So if we talk about sigma 1, that is actually 1 plus 1 plus 1 and so on up to n terms, and thus we have sigma n square, and such type of notation series. Now if we talk about sigma n cube, where n is varying from 1 to n, that is what we're going to discuss in this lecture. Now here we have this, which now formulates to 1 cube plus 2 cube plus 3 cube, and all of this continues up to n cube, right? Now children, here we have the value of this calculated by derivation, which comes to how much? It comes to n times of n plus 1 divided by 2 whole square, right? This is something which you require to remember. That is, if we talk about sigma n cube, then that will be equal to n times of n plus 1 upon 2 whole square, right? So this is a formula. So I'll discuss all of this all over again. Right here we are talking about sigma series, and when we talk about sigma n cube, then we mean to say that n is varying from 1 to n, right? That is the general perception, right? If there is to be a change, then you'll keep a different value for n here, and then it will go on for a different number of terms. So here you have 1 cube plus 2 cube plus 3 cube, and all of this continues up to n cube, and the value of it is n times of n plus 1 divided by 2 whole square, right? Now children, with this we'll be discussing a sum. So initially I'll give you people a little time for trial, and after which I will be expecting that you people would have either tried out the sum, done the sum, or probably if you haven't done the sum, then you'll be looking up the question with full attention, understanding it not just once, because I'll also be giving a second explanation to you, and then I expect you people to pause the lecture again and to do the sum once all on your own, right? With this, there'll be a proper assimilation of all that has been taught, and you'll remember this for a longer duration of time, and also when sums of the same type come, you will be able to handle them. So children, let's discuss this question now. So this next question that I have for you people goes something like this. That is this. So just try this out. At the moment I can just give you very little time, say something like 10 seconds, but you at your home can have an extended time, say some 4-5 minutes, over which you can try out the sum. Even if you do not know anything about the sum, just try thinking, what is it that you can do? Even this way, there are a lot of things which you can do, and you never know, you probably have a new solution to the sum, right? So children, now coming back to the solution of the sum, expecting that you people must have tried this out arduously using all the knowledge that you have at this time. So here we get to see that we've got to evaluate the sum of this series. Now before I start, I'd like to tell you people one thing. I hope you people are sitting at a secluded place on a table and chair, so that there is no mobile, laptop, television, etc. to disturb you, and you're all by yourself, so that there is nobody to talk to you and disturb you. Further, if you sit straight, then you'll be able to understand everything properly. This all has science behind it. So there is nothing that I am concocting, right, or something which is conventional. This is actually a true phenomena which even I follow, and then you will be able to understand the maximum out of whatever the person is trying to tell, right? Okay, now children, here we have to look up this sum, and in this sum there is something which cannot be seen because I have come on top of it. So here you can see that the last number up to which this fraction goes is actually 19 cube. So if you talk about the first term here, that is 1 cube plus 2 cube plus 3 cube, and all of that goes up to 10 cube, and it is divided by 30, right? And then if you talk about the terms which are in between, they are all of the same type. That means they're going to start from 1 cube, and next then they will be going up to 11 cube. In the next term they will be going up to 12 cube, and so on. And if you talk about the denominator, you can see that this is 30. That means this must have been the last number multiplied by 3, although that we will check in the last term as well. So if you talk about the last term here, we have 1 cube plus 2 cube plus 3 cube, and all of that continues up to 19 cube. So the last number is 19. Now 90 into 3 is 57. Thus this also is true, that whatever is the value of the last number cubed, right, if we just multiply that by 3, so that will give us the denominator. Now we've just got to find this out. So obviously this matches with what we've just studied, that means sigma n cube. So first we will talk about the formula that we have studied. That is, we will say that, as we know that sigma of n cube is equal to n times of n plus 1 upon 2 whole square. Remember children, whenever any concept has been given to you, you require to pause the lecture, write it down in your notebooks, and learn it up twice slowly. And then what happens is your brain perceives it. You obviously should be having a fresh brain so that you can accept new knowledge, right? And then just close your eyes and try writing it with the invisible pen, right? This helps you to remember it for a longer duration of time. Again, this is research and development in the memory techniques. Okay, so this is sigma n cube, right, which gives you n times of n plus 1 divided by 2 whole square, right? And we're going to use this formula to find this out. So you find that first what we require is, can anybody in class tell me here? No. Well, first thing that you require is Tn. I'll tell you why. Because whenever you talk about sum of n terms, right, because here also we've got to find out the sum, right? So remember, it is always sigma Tn. That means whenever we require the sum of n terms, in other words, we can say that that is actually T1 plus T2 plus T3, and all of that is going to continue up to Tn. That means when we sum up the n terms, right, it is just like summation of Tn, where again n can vary from 1 to n, right? So it will come out to be the same, right? And summing them up actually is giving you what? It is giving you Sn, right? And that is why Sn is always sigma Tn. So here too, when we require to sum the series, we actually require to find out the sigma of Tn. So obviously we require to find out what the nth term of this series is, right? Now children, if you talk about the nth term of this series, we can write the nth term of this series as, say, some Tn, which is going to be obviously starting from 1 cube going to 2 cube, and all of that is going to continue up to n cube, as we're talking about the nth term. In the 10th term, remember, it was up to 10 cube. So obviously in the nth term it will be up to n cube, and what is going to become the denominator? We've already decoded it. That is 3, which is going to be multiplied with n, right? So this, children, is Tn. Now after you've got Tn, next your task is to find out what this sum of n terms is going to be. So obviously if you talk about the sum of n terms here, children, sum of n terms is going to be sigma of this Tn. Now if we've got to find out this Tn first, and then if we apply Sn, then we'll be able to solve it, and then we'll come to the task of solving it from a specific number to another specific number, right? So let's first try and understand how we can find out Sn, right? And Sn is going to be given by sigma Tn, right? So first we try and solve out Tn, right? And after that we're going to look it up from specific number to specific number, right? So if we talk about Tn here, children, we already have what this Tn is, and this actually is sigma of n cube. Yes or no, right? Because it is 1 cube plus 2 cube plus 3 cube, and all of this continues up to n cube. So this is just sigma n cube, where n is varying from 1 to n. And remember, children, this also has been divided by 3 times of n, right? So here in the denominator we have 3 times of n, right? So if you find this out, then you'll be able to get to Tn. So for the children here, what we do is we can now write this sigma n cube's value, which is n times of n plus 1, which is divided by 2, right? And we also have the whole square of this, and remember, this is divided by 3 times of n, right? Now this obviously can be found out like an expression, and that is what next we are going to do. So we have 1 upon 3, which can be taken common outside, and then we'll have n square times of, we have n square plus 2n plus 1, which is n plus 1 whole square, right? Remember, this is also divided by n, right? And further, 2 square is going to become equal to 4. So we have 1 upon 12, which stands outside. Meanwhile, we simplify, we get to see here that n and n will get cancelled. As such, now what we can do is, when we multiply this n within, we will get n cube plus 2n square plus n, right, which is multiplied with 1 upon 12, right? So this, children, is what this is your Tn, right? And as we've already looked up, that if you want to find out Sn, then that has to be sigma Tn, right? So thus we talk about Sn now, which is sigma Tn, and in this now we keep the values. That is, we will now have sigma of this Tn, that is 1 upon 12, which is multiplied with n cube plus 2n square plus n, right? Now this has to be calculated. Now how do we calculate this? Yes, Umesh? Donald, any idea? Anybody else? Nobody? Well, I'll tell you. Don't you worry. I'm there to look up every problem that you have. You just have to ask me. Just raise your hand this much, and that is more than enough, obviously, for a live class. And if you're not there in a live class, obviously you just require to fill up a small form telling me what your problem is. You'll find me coming to you and helping you out, right? So make sure, do fill up the form, which is there in the description of this video, or which is also there in my profile, right? It's a help form, and the moment you fill it up with the problem that you have, you will get help. Okay, now, children, here further what we do is we get to see here that we have this expression which requires to be solved. Now always remember, there is another rule that you have, that is, if you talk about, say, some sigma notation of, say, any expression, let's say sigma n square, right? And if this n square is multiplied by a constant, then what you do is you take this constant outside, right? And then you have sigma notation of whatever you have to do, right? So if there is a constant which is multiplied with any number whose sigma is to be found out, the constant is going to be taken out of the sigma notation, right? So this is the rule that we're going to apply here. As such, here this 1 upon 12 will come outside, and then inside we have sigma of n cube plus 2n square plus n, right? Now, children, next what you can do is, if, say, you talk about this, here we get to see that we have sigma n cube as well as sigma n square as well as sigma n also, which requires to be put our attention to. So in times to come we will discuss that even, but meanwhile, at the moment, whenever you have sigma which is applied to a sum or a difference of few terms, then sigma goes over to each and every term and does a sigma, that is a summation. So here, as such, 1 upon 12 is still going to be kept outside, and then we'll have sigma n cube, to which is going to be added sigma n square times 2, and to that is going to be added sigma n, and remember all of this is in multiplication with 1 upon 12. As such, we will put up a bracket here. So next we have 1 upon 12, right, which is going to be multiplied with sigma n cube. And here, before putting up the formula, first we'll take the constant outside. That is, here we have sigma n cube, right? Fine. But in the second term, this constant 2 has to be taken outside, so this is 2 times of sigma n square. In all of the terms, we'll keep the formula together, right? But before that, I also have to discuss these formulae with you because yet they haven't been discussed. Okay, so children, here a few formulae. If you talk about sigma n, right, that means the terms are like 1 plus 2 plus 3 and all of that continues up to n terms, right? Then this is given by n times of n plus 1 upon 2, right? This is the formula. Now next, similarly, if we talk about, say, something like sigma n square, then the terms are going to be like 1 square plus 2 square and all of that continues up to n square, right? And for the children, this is given by n times of n plus 1 times of 2n plus 1, right, which is divided by 6, right? So this is the formula, and you should be knowing this formula, that whenever we talk about sigma n, it is actually the terms like n to be all added together up to the nth term, because sigma notation normally means that it starts from 1 and it goes up to n. So the summation comes to n times of n plus 1 upon 2, and when you have terms like 1 square plus 2 square plus 3 square, so up to n square, then that is written like sigma or summation of the terms like n square, and then that is given by a formula n times of n plus 1 times of 2n plus 1 divided by 6, right? So these are two more formulae which you require to learn, which we're going to apply here in this sum. So further now, children, next what you do is you still keep 1 upon 12 outside, right? And inside here now we'll be keeping up the values, that is n times of n plus 1 divided by 2 whole square. Now Sumiran, do you get to see something here? Very good. If we see sigma n, right, sigma n's value was n times n plus 1 upon 2, and when we talk about sigma n cube, it's actually n times n plus 1 upon 2 whole square. Thus it can be written like sigma n whole square, right? Okay, so this is an expression which in times to come probably can be asked in any competitive examination for as an objective question, or probably some other question can be laced in this concept. Okay, so to this is to be added 2 times of the next formula, 10 along with me, n times of n plus 1 times of 2n plus 1 divided by 6. Whenever there is a formula, pause the lecture and first learn up the formula, right? Now to this is going to be added sigma n, that is n times of n plus 1 divided by 2. Now this is a lot of calculation. To simplify it, what you do is whatever is common to all the terms, just take it outside, and as such your calculation is going to be simplified a lot, right? So let's do this now. The simplified calculation, now this is going to be 1 upon 12, which is going to be multiplied with something which can very easily be taken outside, that is n times of n plus 1 divided by 2, which is common to all the terms, right? Just see it. Okay, now when you take this common outside, then inside in the first term you'll be left out with n times of n plus 1 divided by 2, right? And to that then we have here plus, as n times of n plus 1 divided by 2 has been taken outside. As such, 2 in the numerator is left out, 2n plus 1 is left out, and in the denominator we are left out with 3, right? And the last term becomes equal to 1 because all of it has been taken outside, right? So this is going to become what? The sum of n terms. But remember children, we directly don't want sum of n terms. We want something different. We want to find out the sum of the terms when first we started off from the sum of n terms and we go up to the sum of 19 terms. So we actually require the sum of both of these. So just consider one thing, that if suppose we talk about, say, the sum of 19 terms, then what is it going to be? If suppose we talk about the sum of 19 terms, then it is going to be 1 plus and this is going to be divided by 3 times of 1 plus 1 cube plus 2 cube, right? And this is going to be divided by 3 times of 2, right? And all of that is going to continue up to the 19th term, which is 1 cube plus 2 cube plus and so on. This goes up to 19 cube, and then in the denominator we have 3 times of 19, right? Now this is going to be S19. So if from this S19, if we are further able to subtract, say, some S, we've got to go up to how much? S10, right? So if from that we subtract S9, where S9 is going to be 1 cube, which is going to be divided by 3 times of 1, right? And to that is to be added 1 cube plus 2 cube divided by 3 times of 2, and all of that is going to continue up to the last term, which will be 1 cube plus 2 cube plus and so on up to 9 cube, remember, and all of that gets divided by 3 times of 9, right? Then we will have got the sum of 9 terms. And if from the above series, if we subtract this, won't we start getting the terms from 1 cube plus 2 cube and so on up to 10 cube divided by 3 times of 10, right, as we required, and then it will go on up to 1 cube plus 2 cube and so on up to 19 cube divided by 3 times of 19. That means the terms which are common will get cancelled. So this is what we are going to do in order to get to this sum that we require, right? So further here, next what we do is, in order to find out the sum of this series, let us consider it to be named as 10, right, to 19. Okay, so this is going to be found out by S19, from which is going to be subtracted S9, right? Now children, here we will substitute values in the sum expression that we got, right? Remember, it was 1 upon 12 times of, in place of n for the 19 series we've got to keep 19, and for the 9 series we've got to keep 9. So this is then going to become equal to 1 upon 12, which all through is going to be common, and then further we will have here n times n plus 1 upon 2. So that is going to become equal to, again, that can be written without the brace bracket, right? So here we will have n, which is 19, and it will be multiplied with 19 plus 1, and it is to be divided by 2, right? And further inside here you will again have 19, which is multiplied with 19 plus 1 divided by 2, to which is going to be added plus 2 times of 19, right? And then to it is added 1, and it is divided by 3, and to that is added 1, right? So this is S19, right? And from this is to be subtracted the second term, which is S9. So that is going to become equal to 1 upon 12 times of, we have 9 times of 9 plus 1, which is divided by 2, and inside then we will have 9 times of 9 plus 1 divided by 2, from which is, to it is going to be added 2 times of 9 plus 1 divided by 3, right? So everything proper here, yeah, everything is proper. Now to that is added 1, right? And this is all that it is. Now here what we have is, as we have certain things which can be taken common and cancelled off, so we'll do that simplification. So here for the children, we get to see that we can cancel now here. If we talk about the first term, we have here 1 upon 12, which can be written as 1 upon 4 into 3, right? And then we have 19, which is multiplied with 20, and it is divided by 2, right? And to that further is multiplied 19 times of 20, and it is divided by 2, right? And then to it is added 2 times of 19 twos is 38 and 1 is 39, right? And it is divided by 3, and to it is added 1, right? And from this is subtracted 1 upon again 4 into 3, and that gets multiplied with 9 times of 9 plus 1 is 10 divided by 2, and further within the bracket we have 9 times of 10, right, which is divided by 2. And further after that we now have here a little more, that is the second term, which is 2 times of 2 9 is 18 plus 1 is 19, which is divided by 3, right? And to it is added 1, right? So this is all that you're going to do. You will find that there are a lot of things which will get cancelled, and as such your calculation is going to become damn simple. So let's do it. Now here you have that there is this 1 upon 12 also. Whoa. Well, okay, just a second. So here we have this 1 upon 12. So as such 4 gets cancelled with 25 times, right? And then further we have here 1 upon 6, which still remains, doesn't matter, whatever can get cancelled we've got to cancel it. 2 gets cancelled with 10 times, and 3 gets cancelled with 13 times. And then further if you talk about the next term, we have 2 which gets cancelled with 10 5 times, and then we have 3 which gets cancelled with 9 3 times, and then further we have now 2 which cancels 10 5 times, and further here no cancellation which is possible, right? And further here we have the next term, which was 2 into 13. Okay, this was 3 into 39. Okay, now let's quickly calculate the second one, whether that has any mistake or not. We have here in the second term what we have 2 times, so 2 9s are 18 1 19. No cancellation is possible. So as such here now we'll further calculate whatever is rest, right? So here as such we are left out with 19 into 5, right, which is divided by 6, and further then we have here 19 into 10, which becomes equal to 190, to which is to be added 30 into 2, which is 26, to which is to be added 1, right? And from that is to be subtracted. Here we have 3 into 5, which is 15, and it is divided by 4, right? And further then within we have here 9 to 5, which is 45, to it is added 90 into 2, which is 38, which is divided by 3, and to that is added 1, right? Now we further calculate this. So here as you find that this is a lot of calculation, so I think this calculation you can easily do, right? Because there's nothing much in it, right? Although I can do this. So here you will have 90 into 5.6, right? And this is to be multiplied with 90 plus 26, which will become equal to 210 216 217, right? This is not going to get cancelled with 3 or 2, right? And from this is to be subtracted 15 upon 4 times of 45 into 3. We'll have that is going to become equal 3 5 15, 1 remainder, 3 4 12 1 13, 135, right? To which is going to be added 38, and is to be added 3 more. So 5 and 3 is 8, 8 and 8 is 16, 1 remainder, 3 and 3 6 and 1 is 7, so you have 176, right? So as such here we have 176, right? Now this can get cancelled with 2. We'll try out with 4. Even with 4 it'll get cancelled. So 4 4s is 16, 1 remainder, 4 4s is 16, so this goes 44 times, right? So now let's calculate this long thing. So this is going to become equal to 19 into 5, right? 5 9s is 45, and then we are left out with 4. 5 1s are 5, 5 and 4 is 9, so this becomes equal to 95, right? And that is further to be multiplied with 217, right? Okay, so 217 multiplied with 95, right? 5 7s are 35, 3 remainder, and then we have 5 1s are 5, 5 and 3 is 8, 5 2s is 10, and then we have 9 7s is 63, 6 remainder. Then we have 9 1s are 9, 9 6 is 15, 1 remainder. Then we have 9 2s are 18, and 1 is 19, right? We add these up, so this becomes equal to 5, 8 and 3 is 11, 1 remainder. 5 and 1 is 6, 9 1 is 10, 0 1 2. So 20615, right? And it also has to be divided by 6, right? And further here from this is going to be subtracted the product of 44 with 15. Now 15 4s will be 60, so if you multiply 60 with 11, right, your task is going to be done. So 6 1s is 6, excuse me, so this is going to become equal to 660, right? And further what we do is we now divide this, right? So 6 3s is 18, and then 2 remainder. 6 4s is 24, 2 remainder. Then we have 6 3s is 18, and then we have 6 5s is 30, and 5 remainder, 5 upon 6. Now that can also be calculated in decimal points, so thus that will become equal to 50. It will become 6 7s is 42, and 6 8s is 48, right? 2 remainder, 20. So 6 3s is 18, and from that is to be subtracted 660. And now when we subtract, this is going to be 0.83, and then further we will have 5 here, and next we will have 6 and 7 is 13. Then we have 7 and 7 is 14. So we have 2775.83, which becomes the final answer, right? So all of this I'll just quickly discuss so that if there is any doubt at any point of time, all of that gets cleared, right? So in the question, children, you've been given here that you have to find out the sum of a series in the garb of two terms being subtracted, right? That is the sum up to 10 terms, and the terms the sum up to 19 terms is what you're going to find out. As such, now from the sum of 19 terms, if you subtract the sum of 9 terms, then you will be able to get to the answer, right? So let's first look up this series as it is. Normally it is actually sigma n cube type. That is, it is just like 1 cube plus 2 cube plus and so on up to n cube, but it is also divided by 3 times of n, right? As here in the first term we have 30, and in the last term also we get to see that this is 19 into 3, right? So as such, here next what you do is you now here have this sum to be further written as in the numerator to be sigma n cube, and in the denominator 3n, where n is varying from 1 to n, right? So further here you keep the value of sigma n cube, that is n times n plus 1 upon 2 whole square, and divide it by 3n. So next what you do is, if you keep this value of n times n plus 1 upon 2, you'll find that one part of n will get cancelled from the numerator and from the denominator, and then you'll have 1 upon 3, which is multiplied with n times n plus 1 upon 2 whole squared, will become n squared plus 2n plus 1, and which is divided by 4, as 2 square is going to become equal to 4. Next what you do is you just multiply this n within, so it will become n cube plus 2n square plus n, right? And then further you have 1 upon 12. So next now what you do is, if you talk about Sn, it is actually sigma Tn. That means whatever was the sum of n terms, right, that is to be first term plus second term plus third term and so on, will give you actually Sn. That is sigma n is actually Sn is actually sigma Tn, right? And thus here, if you talk about adding up the first term to the second term and so on up to the nth term, you will get to Sn, right? And here, as we see that we get our sum of n terms to be n cube plus 2n square plus n. Right here, whenever there is a constant which is multiplied with a sigma notation, you just keep that constant outside and you go ahead with the sigma notation. So here too we are going to do the same. So we have this 1 upon 12 which is going to be kept outside, and inside we have sigma n cube plus 2n square plus n. Now further, when you solve this out, so this becomes equal to sigma n cube plus, again we will have to take this 2 outside from sigma n square, and then this is how the notations are going to be. Now you keep the formulae as I told you, that sigma n is the same as n times n plus 1 upon 2, right? If you talk about sigma n squared, then that is n times n plus 1 times 2n plus 1 divided by 6, right? And further here what we do is we now have this where we can take this n times n plus 1 upon 2 common outside, and inside then here you'll be left out with n times n plus 1 upon 2. Here when n times n plus 1 upon 2 is taken outside, you'll be left out with 2 times 2n plus 1 upon 3, and here all would have gone outside. As such, one which is multiplicative identity will be left out. Now children, remember, as you will find out from 1 cube plus 2 cube and so on up to 10 cube, up to 1 cube plus 2 cube, up to 19 cube, right? So as such, what we require to do is we require to subtract from S19 S10, right? And as such, what will happen is then we'll be able to get to the answer. So as such, here this is what is done. First S19 is found out, then S9 is found out, then we find out the mutual subtraction to get the sum of the terms from S10 to 19, right? This is how it has been named. Okay, so S19 will be just writing the first term, writing the second term, and going on up to the 19th term, right? And similarly, the S9 is going to be written like first term plus second term and so on, going up to the 9th term, right? Now children, when we find out the mutual subtraction of both of these, we will actually get from the term S10, right? That is 1 cube plus 2 cube and so on up to 10 cube divided by 3 times of 10, so on up to 1 cube plus 2 cube, so on up to 19 cube divided by 3 times of 19, right? And now in this, now we substitute values of n for the S19 series and for the S9 series, and for the simplifier, just that's it. Now further here we find that after we put up the values, there are a lot of things which will get cancelled, so we cancel it off, and further after cancelling off, we are left out with certain calculations which have to be done, so we do it and we get to our final answer. Now this is something which I was wanting to avoid because this is something that you can easily do. You've been doing calculations since junior classes, so I think you people have been able to understand this. Yes, for sure. That's very good, children. Now this is actually what gives me a lot of pleasure, to be able to explain things to you which are normally inexplicable to you. Now you can have a better idea about how I do things in a live class where we'll be discussing a lot of sums. We'll be discussing the concepts in detail, and if you have any doubt, you will get help readily. Moreover, there are a lot of resources like self-paced courses, right? Shorts and longs, problem resolution sessions, tests, etc. One-to-one sessions where I discuss your career perspective, and a lot to be done when you join live with me. For that, you just have to fill up a form which is there in the description of this video, or it is there in the description of my channel. Just as you open up my channel, just on top you will get clickable links. In that, get to the form link and then you can join me. Moreover, there are other links which you can join, like you can join my Instagram for the shorts. Then there's a Facebook group, right? If you join it, then I put you in a group where you have group learning with challenges, right? So you have to get to the challenges, and when you meet the challenges, then you are leveled up. So make sure that you join in the live class, have a good idea, right? Because you should get the best so that you can bring the best result, right? Because this is Join Joyous Journey from education to employment, right? So bye children, have a nice time. Bye.